For absolute value inequalities, there's two cases to consider for us. Are we less than a number or greater than it, possibly equals? So for the absolute value of x less than or equal to 4, I want to answer this by looking on a number line. So just draw something really basic here. And the goal is to guess all of the numbers that make this thing a true statement. So I'm going to pick a few that I know work for sure. So we're just guessing some x's, like, okay, 0. 0 definitely works because the absolute value of 0, is that less than or equal to 4? Well, yeah, because 0 is less than or equal to 4. On our number line, we can say, okay, at 0, that is a value that works. And if you go back and think about it, well, okay, 1, 2, 3, and 4 have to work as well. In the absolute value, they would just equal the number itself, and that's always either less than or equal to 4. So I know, all right, 1, 2, 3, 4, those all work, and all the numbers between them as well. So those are good. But if you try something like 5, at 5, it is no good. So ones that don't work, like 5, this does not work because the absolute value of 5 is that less than or equal to 4. Well, no, because this is a false statement, so no good. There are more values that work. We could try negative ones. So how about adding to the list? Maybe -1, -2. The absolute value of -1, is that less than or equal to 4? Well, sure, because 1 is less than or equal to 4, so we can include that, -1. Same thing holds true for -2 and -3, all the way up till you get to -4. So -1, -2, -3, -4, these are all okay. And everything in between. But if you try something like -5, that will not work anymore. So the absolute value of -5, is that less than or equal to 4? No, because 5 is not less than or equal to 4. So again, this is false. The thing to point out here is that if you say the absolute value is less than or equal to a number, that not only gives you a bound for 4, but you have to stop at -4 too, because the second you pass it, these values become positive again, so they don't work. Every single absolute value that's less than or equal to a number will look like this. We're going to be trapped between the negative and positive of it. So another way to state this inequality is, not only are you going to be less than or equal to 4, but you have to be greater than or equal to -4. So these two things are equivalent. If you have one, you have the other. Now, if you compare this to the absolute value of x is greater than 6, this is going to be the opposite scenario, where we're not going to be trapped between two values. We're going to be on the outside of two values. So maybe I'll list this one out just a little bit quicker here. A value like 0 will not work. But if you want to choose something like 7, well, that's definitely okay. Like, you can go out to 7 and say, well, okay, 7 definitely works for sure. But so does -7. So does 8 and -8. All of those values going away from 0 must work. And the reason is, when you put them into the absolute value, they become positive, and they're always bigger than 6. In fact, you can go right up until you get to -6 and +6. You just can't use either of those because there's no equal sign in the original inequality. So if you have an absolute value that is greater than a number, it'll look like this. It's going to be the outsides of two given values. So you can break this apart into, okay, x has got to be bigger than 6, or x is less than -6. So those are like your two possibilities. You're either trapped between two values, or you're on the outside of two given values. So in example 1, I'd like to solve this slightly more complicated absolute value inequality. It's the absolute value of x plus 4 is less than 1. So we'll graph the answer on a number line, but the goal is to first just get rid of the absolute value. So we don't need this symbol anymore. I know that this is going to become, all right, it's got to be something less than 1, but also something bigger than -1. Because we have less than, we are trapped between two values, the positive and negative of the number that's outside here. And then I'll just copy down x plus 4 in between those two values. So these two statements are equivalent. If you have the absolute value of x plus 4 is less than a number, and you want to get rid of the absolute value symbol, you'd have to write it like this. We are both less than 1, but bigger than -1. The only difference here is now the expression between them is a little bit more complicated. So to solve this inequality, all we have to do is get x by itself. So we can treat it like an equation where, okay, I have x plus 4, so I got to subtract 4. But I want to make sure that I do that to, oh, well, I got to take 4 from this 1. But you're also doing the same thing on the left side too. So you can do this all in one step. If you subtract 4 from this piece, well, you'd have to subtract 4 from here. But you're taking 4 from everything. The net result is going to be, all right, we got -5. We have less than. We have just x. And then we still have less than. And we get -3. So this is the final answer. If you're looking to graph this on a number line, okay, let's see, we got, maybe I'll put -5 here, and -3 is located here. We're saying that's everything between those two values. So this is my solution, everything from -5 to -3, but between those values. And for example 2, just the other scenario, here we have an absolute value, but this time it's greater than or equal to a number. So if we want to solve this without referring to a number line first, I have to get rid of the absolute value symbol. So what this means is I'm going to take 2x plus 5, and this has to be bigger than or equal to 17. So we're saying we're on the right side of 17. But we also want that 2x plus 5 is less than or equal to -17. So maybe I will just put a number line up here to start with. For this original inequality, the focus is 17. So you got positive 17 and -17. I know since the inequality is greater than or equal to, I have to be on the outside of those two values. So I got to be in this direction or this direction. And that's where these two inequalities come from. You're saying, well, I want the thing to be bigger than 17, which is referring to this stuff over here. But you also want this to be less than or equal to -17, which is what this statement says here. I'll just put or between these two. So this you have to do separately if you have the outsides. You got to break it up into two separate pieces. But solving it is the same way, where I'm going to subtract 5 from both sides of my inequality, and I get 2x is bigger than or equal to 12. And then I'm going to divide both sides by 2, and I get x is greater than or equal to 6. My second inequality is going to look really similar. I'm still going to take 5 from both sides. I get 2x, it's now less than or equal to, okay, and I get -22. And after I divide both sides by 2, I get x is less than or equal to -11. So to put this on a number line, the first one up here was referring to 2x plus 5, but now we've reduced it to just x. So I have the value 6 and the value -11. I'm greater than or equal to 6. I'm less than or equal to -11. All of those numbers represent the solution to the original inequality.